Good morning, students. For today's lecture, our topic is congruence relation on semigroup. Okay. So first of all, the definition: let A star be a semigroup. A relation R defined on set S. So first of all, what is the relation? Relation R is the subset of S cross S. Okay. So we have discussed in the earlier lectures. So relation R defined on set S is said to be congruence relation if it satisfies following conditions. Okay, there are two conditions. First one is R is an equivalence relation on set S. What is R? R is an equivalence relation on set S. That means R is reflexive, R is symmetric, and R is transitive. Okay. And for A, B, C, D belongs to S, if A is related to B and C is related to D, then A star C related to B star D. If these two conditions are satisfied, then we can say that R is congruence relation on semigroup S star. Okay. In other words, we can say that an equivalence relation R on semigroup S star is called congruence relation. What is equivalence relation? Is said to be congruence relation on semigroup if A related with A dash and B related with B dash, then A star B related with S dash star B dash. Here we have considered binary operation for our semigroup. Okay, I have changed the notation here, but it's okay. This is the thing of just notation. You can use any notation. Okay. Now let us see next our example of the congruence relations. Let S star be any semigroup, then equality relation delta is a congruence relation of S star. What is the equality relation? Equality relation means A related with B if and only if A is equal to B. Okay. Here delta is an equality. What is our aim? Our aim is to show that equality relation is congruence relation. So for any relation, first of all we show that this is equivalence relation. Then after we improve the second condition. Okay. So here delta is an equality relation on set S star. Okay. So relation is subset of S cross S. So delta is the subset of S cross S. How it is given? A delta is equal to order pair AA, where A belongs to S. Now we saw that equality relation is an equivalence relation. Okay. So for any A belongs to S, it is clear that A is equal to A. So AA belongs to delta. This implies A delta A. So reflexive property is satisfied. Now consider AB belongs to delta. Okay. Then A is equal to B. So we can write as B is equal to A. So B order pair BA belongs to delta. So A delta B is equal to B delta A, as A is equal to B. So symmetric property is also satisfied. That means equality is an symmetric relation. Now similarly for 2 order pair AB belongs to delta and BC belongs to delta, then A related with B by equality relation. So A is equal to B and B is equal to C. From this we can say that A is equal to C. So order pair AC belongs to delta. Okay. This implies that A delta C. Hence transitive property is also satisfied. So delta is equality relation is reflexive, symmetric and transitive. So it is an equivalence relation. Okay. Now consider A, B, C, D belongs to S such that A delta B and C delta D. Okay. That is A is related with B and C is related with D. Okay. This implies that A is equal to B and C is equal to D. Okay. Now A is equal to B. So A star C is as similar as B star D, because A is equal to B and C is equal to D. So A star C is equal to B star D. So these both element are same. So A star C delta B star D. Okay. So this shows that delta is a congruence relation on set S. Okay. तो ऐसे एग्जाम्पल में हमको क्या करना होगा, सबसे पहले तो हमको जो रिलेशन दिया हुआ है उसको इक्विवेलेंस रिलेशन है ऐसा दिखाना होगा। उसके बाद क्या करना होगा, जो हमारी सेकंड प्रॉपर्टी है उसके लिए हमको 4 एलिमेंट कंसीडर करने होंगे हमारे सेमी ग्रुप से। उसके बाद उसका जो प्रोडक्ट है बाइनरी ऑपरेशन वाला, वो भी जो रिलेशन उनको दिया हुआ है उसमें मिलता है, तभी हम कह सकते हैं कि जो दिया हुआ रिलेशन है वो कॉन्ग्रुएंस रिलेशन है। ओके, सो इसमें भी हमारा जो ए इज रिलेटेड विथ बी है और सी इज रिलेटेड विथ डी है, तो इसका प्रोडक्ट हमने सी के साथ लिया और सेकंड वाला जो एलिमेंट है उसका प्रोडक्ट हमने फोर्थ वाले एलिमेंट के साथ लिया है। ओके, सो ए स्टार सी इज इक्वल टू बी स्टार डी। ओके, सो उसके बाद हमको क्या मिला, ए स्टार सी इज रिलेटेड विथ बी स्टार डी। ओके, सो फर्स्ट एलिमेंट का प्रोडक्ट थर्ड एलिमेंट के साथ और सेकंड वाला का प्रोडक्ट फोर्थ एलिमेंट के साथ। ओके, इस तरीके से हमको सेकंड कंडीशन को प्रूव करना है और इसके बाद हम कह सकते हैं कि गिवन रिलेशन इज कॉन्ग्रुएंस रिलेशन ऑन S star for a given semigroup. Okay, let us see example number 2. Consider the semigroup Z plus and the relation R on Z defined by. Okay, यहाँ सेमी ग्रुप कौन सा दिया है वो खास ध्यान रखिएगा। हियर हमको सेमी ग्रुप दिया है Z प्लस। ओके, इफ वी चेंज दिस बाइनरी ऑपरेशन देन कॉन्ग्रुएंस रिलेशन विल ऑल्सो चेंज। ओके, यहाँ बाइनरी ऑपरेशन का बहुत इंपॉर्टेंस है। सो हमको इधर सेमी ग्रुप दिया है सेट ऑफ ऑल इंटीजर्स विथ बाइनरी ऑपरेशन एडिशन। ओके, एंड रिलेशन कैसे डिफाइन हुआ है, रिलेशन इज ए इज रिलेटेड विथ बी इफ एंड ओनली इफ ए इज कॉन्ग्रुएंट टू बी मॉड्यूलो एन। ओके, दिस इज read as how this is read, A is congruent to B modulo n. Okay, that means A is related to B if and only. What is the meaning of this? That means n divides A minus B, or we can say that A minus B is multiple of n in Z, or in other word we can say that A minus B yield same remainder when divided by n. इसका मतलब क्या होगा कि अगर a और b को हम जब n से डिवाइड करते हैं तब जो रिमाइंडर मिलता है वो दोनों केस में सेम होता है। दैट मीन्स whenever we divide a by n we get the same remainder r. Similarly whenever we divide b by n we get the same remainder r. In both cases we get the same remainder. Okay, so all these are equal, all these three statements are equal. Okay, so A is related to B if and only if A is congruent to B modulo n. Okay, so what is our aim? Our aim is to show that Z plus under this relation, for this relation R is a congruence relation on semigroup Z plus. Okay, so to show this is congruence relation, first of all we show that given relation is equivalence relation. Okay, so first is the reflexive property. So for any A belongs to Z, A minus A is equal to 0. Okay, and 0 is divisible by any element, instead of any element. Okay, any non-zero element. 0 is divisible by any non-zero element, so n divides A minus A is equal to 0. So this implies that A is congruent to A modulo n. Okay, so A is related with A is related with A, that means congruence relation, congruence modulo n is a reflexive relation. Okay, now next is let A B belongs to Z such that A is congruent to B modulo N. This implies that N divides A minus B. Okay. Now whenever A minus B belongs to Z, okay, these both are element from Z, so A minus B belongs to Z, divisible by N. So B minus A also belongs to Z. Okay, because there is just a change of sign. So N divides A minus B. This implies that N divides B minus A. This implies that B is congruent to A modulo N. So B is related with A. Okay. So congruence modulo N is symmetric. Now third one is transitive property. For that, consider three element A, B, C belongs to Z such that A is congruent to B modulo N and B is congruent to C modulo N. Now A is congruent to B modulo N, that means N divides A minus B, and B is congruent to C modulo N, that means N divides B minus C. Okay, this implies that N divides A minus B plus N A minus B plus B minus C. Okay, so हमें अगर कोई दो डिजिट दिए गए हुए हैं और वो दोनों डिजिट 5 से डिविजिबल है तो उसका सम भी 5 से डिविजिबल होगा. ओके, इफ यू कंसीडर 10 and 15, then 10 is divisible by 5 as well as 15 is divisible by 5, then 10 plus 15 is equal to 25 is also again divisible by 5. Okay, we use this law in this step. Okay, so N divides A minus B and N divides B minus C. So this implies that N divides A minus B plus B minus C. So by simplification we get N divide A minus C because B is cancelled out. Okay, so N divides A minus C. This implies A is congruent to C modulo N. Okay, so this is transitive. Okay, so congruence modulo N is an reflexive, symmetric and transitive. This means this relation is an equivalence relation. Okay, now we saw our second property. For that, consider four element A, B, C and D belongs to Z such that A is congruent to B modulo N and C is congruent to D modulo N. Now what is our aim? Our aim is to show that for given semigroup is, what is our semigroup? Our semigroup is Z plus. Okay, our binary operation is addition. Okay, so now we add A plus C is congruent to B plus D modulo N. What is our aim? Our aim is to show that A plus C is congruent to B plus D modulo N. Okay, now from this A is congruent to B modulo N, this implies that N divides A minus B. Similarly, N divides C minus D. Okay, this implies that N divide A minus B plus C minus D. Now again, simplify this step, we get N divide A plus C minus common and we get B plus D. Okay, so N divide A plus C minus B plus D. This shows that A plus C is congruent to B plus D modulo N. Okay, hence congruence modulo N is a congruence relation on Z plus. हमने यहाँ क्या देखा? बाइनरी ऑपरेशन हमारे पास एडिशन है. ओके, सो हमको क्या करना होगा? तो ये दोनों हमने जो चार एलिमेंट लिए हैं उसमें से हमने दो रिलेशन डिफाइन किए हैं. A इज रिलेटेड विथ B एंड C इज रिलेटेड विथ D. ओके, सो जो फर्स्ट एलिमेंट है उसका एडिशन करना होगा. सो A प्लस C और सेकंड एलिमेंट का भी एडिशन B प्लस D. ओके, so this the second property is also satisfies. Okay, so this congruence modulo N is a congruence relation on Z plus. Okay, अब हम क्या करेंगे? हमारे पास इधर सेमी ग्रुप Z प्लस था, बाइनरी ऑपरेशन एडिशन था. अब हम क्या करेंगे, बाइनरी ऑपरेशन को चेंज कर देंगे. एडिशन इज रिप्लेस्ड बाय मल्टीप्लिकेशन. इन नेक्स्ट एग्जाम्पल वी विल रिप्लेस एडिशन बाय मल्टीप्लिकेशन. ओके, बाइनरी ऑपरेशन हम चेंज कर देंगे. तो क्या होगा देखते हैं. एग्जाम्पल नंबर 3. फिक्स n बिलोंग्स टू n, डिफाइन रिलेशन r ऑन सेमी ग्रुप z मल्टीप्लिकेशन. मैंने क्या बताया था, हमने बाइनरी ऑपरेशन चेंज किया है. एग्जाम्पल नंबर 2 में बाइनरी ऑपरेशन एडिशन था, इधर हमने क्या किया है, मल्टीप्लिकेशन. ओके, रिलेशन इज डिफाइंड एज a is related with b if and only if a is congruent to b modulo n. रिलेशन सेम है लेकिन बाइनरी ऑपरेशन चेंज हो गया. Then prove that R is a congruence relation on Z multiplication. Okay, semigroup is Z with multiplication. Okay, so first of all we saw that given relation R is an equivalent relation. Okay, from example number 2 we have already discussed that congruence modulo n is an equivalence relation. Okay, so from previous example 2 it is clear that congruence modulo n is an equivalence relation on Z. Okay, now what is it is enough to show that our only second property. Okay, for that consider four element a b c d belongs to Z such that a is congruent to b modulo n and c is congruent to d modulo n. Okay, हमने क्या किया, जो सेकंड प्रॉपर्टी है वही हमको प्रूव करना पड़ेगा. फर्स्ट प्रॉपर्टी तो हमने एग्जांपल नंबर 2 से कंसीडर कर ली है. So from this we can say that n divides a minus b, and from this n divides c minus d. Okay, now what is our aim? Our aim is to show that AC, because our binary operation is multiplication, that means AC is congruent to BD modulo n. Okay, what is our aim? Our aim is to show that AC is congruent to BD modulo n, that is n divides AC minus BD. Okay, so how we can prove that, let us see. Now n divides AB, that means A minus B is multiple of n in Z. Okay, A minus B is multiple of n in Z, that means A minus B is equal to nx for some x belongs to Z. Similarly, n divides C minus D. This implies that C minus D is multiple of n in Z. So C minus D is equal to ny for some y belongs to Z. It is clear. Okay, simple explanation. Now AC minus BD. What is our aim? Our aim is to show that n divides AC minus BD. Now AC minus BD is equal to AC minus AD plus AD. We have add plus AD, we have add AD and remove AD. So we get this step. So AC minus BD is equal to AC minus AD plus AD minus BD. Take A common, we get A into C minus D plus, from this step take D common, we get D into A minus B. Now C minus D is equal to ny, and A minus B is equal to nx. Okay, so take n common from this step, we get n. So in this step what we get, A into ny plus D into nx. Take n common, we get a n into ay plus dx. Okay, since a d y x, all these elements are from Z. Okay, all these elements are from Z, so their product and their addition also belongs to Z. Okay, so take this element ay plus dx is equal to x dash. Okay, so what we get, AC minus BD is equal to nx dash. AC minus BD is equal to nx dash. This implies that AC minus BD is multiple of n in Z. Okay, what is AC minus BD? AC minus BD is multiple of n in Z, that means n divides AC minus BD. Okay, n divides AC minus BD. This shows that a sim is congruent to BD modulo n. Okay, so second property is also satisfied. So given relation R is an congruence relation on semigroup Z plus Z with binary operation मल्टीप्लिकेशन. ओके, सो किसी भी एग्जाम्पल में हमको सबसे पहले क्या देखना है, हमको रिलेशन कौन सा दिया हुआ है, उसके बाद जो सेमी ग्रुप दिया हुआ है उसका बाइनरी ऑपरेशन क्या है, ये दो इम्पोर्टेंट चीज़ है. उसके बाद हमको इक्विवेलेंस रिलेशन ऐसा बताना है और जो ये वाली प्रॉपर्टी है वो भी दिखानी है. सो लेट अस मूव टू द एग्जाम्पल नंबर 4. Example number 4 is, give an example of equivalence relation R on Z plus such that R is not a congruence relation. इस एग्जाम्पल में हमको क्या करना है, ऐसा इक्विवेलेंस रिलेशन का एग्जाम्पल हमको देना है जिसकी वजह से जो R है वो इक्विवेलेंस रिलेशन तो होगा पर कॉन्ग्रुएंस रिलेशन नहीं होगा हमारे गिवन सेमी ग्रुप के ऊपर. ओके, so consider the semigroup Z plus where plus is ordinary addition. Okay, consider the polynomial fx is equal to x square minus x minus 2. This also can be written as, factorize this polynomial, we get x minus 2 and x plus 1. Okay, so 2 and minus 1 are the root of this polynomial. Okay, now we define the following relation on Z. How we define the relation? A is related with B if and only if f of A is equal to f of B. Okay, that means the images of A and B are same whenever it puts in this polynomial. Okay, the value of A and B are same in this polynomial. Now we saw that R is an equivalence relation on Z. Okay, we have defined relation. A is related with B if and only if f of A is equal to f of B. Okay, what is our aim? Our aim is to show that this is equivalence relation but not congruence relation. Okay, so first of all we saw that this is equivalence relation on Z. Okay, so it is clear that for all A belongs to Z, f of A is equal to f of A. Okay, that means A is related with A, so R is reflexive. It is very easy thing. Now for two element AB belongs to Z, consider A is related with B. Then f of A is equal to f of B, so f of B is equal to f of A. So B is related with A. So there is also easy explanation of symmetric property. So from this R is symmetric. Now third one is R is transitive. So let A, B, C belongs to Z such that A is related with B and B is related to C. Okay, from this we can say that f of A is equal to f of B and f of B is equal to f of C. So f of A is equal to f of C. So A is related to C. Okay, so this shows that R is transitive. So R is an reflexive, symmetric and transitive. So R is an equivalence relation on Z. Okay, अब हमको क्या करना है, R इक्विवेलेंस रिलेशन तो हो गया, हमारा एम क्या है, हमारा एम ये है कि R इज नॉट कॉन्ग्रुएंस रिलेशन ऑन Z प्लस. ओके, आवर सेमी ग्रुप इज सेट ऑफ ऑल इंटीजर्स विथ बाइनरी ऑपरेशन एडिशन. ओके, सो उसके लिए हमको क्या करना होगा देखते हैं. Now our polynomial is f of x is equal to x square minus x minus 2. Factorization gives x minus 2 x plus 1. Okay, so minus 1 and 2 are zeros of this polynomial. So f of minus 1 is equal to 0 and f of 2 is equal to 0. From this we can say that minus 1 is related to 2. Okay, similarly we find another two element minus 2 and 3. Okay, now f of minus 2 is equal to minus 2 minus 2 minus 2 plus 1. This is minus 4 into minus 1. This is equal to plus 4. And f of 3 is equal to 3 minus 1 into 3 plus 1. This is equal to 4. Okay, so images of minus 2 and 3 both are same. Okay, so minus 2 is related to 3. Okay, अगर हमारा जो रिलेशन डिफाइन किया हुआ है वो कॉन्ग्रुएंस रिलेशन होगा तो क्या होगा, -1 प्लस -2 इज रिलेटेड विथ 2 प्लस 3. Okay. Okay. Now we will check this is happens or not. So -1 plus -2 is equal to -3 and f of -3 is equal to 10. Okay, this is simplification. F of -3 is equal to 10. Now 2 plus 3 is equal to 5. Now what is the f of 5? Let us see. 2 plus 3 is equal to 5 and f of 5 is equal to 18. Okay, f of 5 is equal to 18, f of -3 is equal to 10. Okay, so f of -3 does not equal to f of 5. F of -3 does not equal to f of 5. This implies that -3 does not related with 5. -3 is not related with 5. So -1 -2 is not related with 2 plus 3. Okay, so इसकी वजह से हमारी सेकंड प्रॉपर्टी है वो सेटिस्फाइज नहीं हो रही है. सो हम क्या बोल सकते हैं, hence R is not a congruence relation on Z plus because our second property is not satisfied. So you can find another you can define another equivalence relation on this set. Okay, in this on for this semigroup Z plus. Okay, you should find out in it your homework. Okay, you should find out another equivalence relation such that this equivalence relation will not be congruence relation on semigroup Z plus. Okay, now example number 5 is about the free semigroup generated by A. So let us see. Let A is equal to set 0 1. Okay, and consider the free semigroup generated by A with binary operation catenation defined on. Okay, what is A is set with two elements 0 and 1 and semigroup is A star with binary operation catenation. Okay, now define the following relation on A star. What is the relation? Alpha related with beta if and only if alpha and beta have the same number of ones. Okay, what is the A star? A star is the free semigroup generated by A with binary operation catenation. Okay, so तो A star में जो एलिमेंट होंगे वो कैसे होंगे? सेट ऑफ ऑल सीक्वेंसेस विथ सिंबल्स, set of all finite sequences with symbols from A. Okay, so इस A star में क्या होगे? finite sequences होगी, उसमें कौन से digits और symbols आएंगे? 0 और 1. Okay, 0 1 0 1 वाली finite sequences होगी A star में. Okay, so whenever we consider two finite sequences alpha beta belongs to A star, then alpha related with beta if and only if both have the same number of ones. Okay, then what is our aim? Our aim is to show that R is congruence relation on A star. So let us see. First we saw that R is an equivalence relation. Okay, since it is clear that for any alpha belongs to A star, alpha is related with alpha because the number of ones in both the cases are same. Okay, so R is a reflexive. Now अब हमको क्या करना होगा? Since it reflexive property is satisfied, now consider two element alpha beta belongs to A star. Now alpha related with beta, this implies that alpha and beta have the same number of ones. This implies that beta and alpha have the same number of ones. So beta related with alpha. These are the simple. Okay, simple explanation. So R is symmetric. Now consider three element alpha beta gamma belongs to A star. Now alpha related with beta and beta related with gamma. This shows that alpha and beta have the same number of ones and beta and gamma have the same number of ones. Okay, so the number of ones in alpha and beta are same and beta and gamma are same. This shows that alpha and gamma have the same number of ones. Okay, this implies that alpha related with gamma, so R is transitive. Okay, from all these three property, R is an equivalence relation. Now R is an equivalence relation. Now we show the second property. For that, consider the four element alpha, beta, gamma and delta belongs to A star, such that alpha related with beta and gamma is related with delta. Okay, so alpha and beta have the same number of ones. Alpha and beta have the same number of ones, and gamma and delta have the same number of ones. From this, alpha and beta have the same number of ones, and gamma and delta have the same number of ones. Okay, now what is our binary operation? Binary operation is catenation. What is the catenation? We have combined two finite sequences. Okay. So the number of ones in alpha catenation gamma is the sum of the number of ones in alpha and the number of ones in gamma. Okay, how we define catenation? We define catenation as the combination of two finite sequences. In alpha, if there are 4 ones, and if in gamma there are 5 ones, then the number of ones in alpha catenation gamma is sum of 4 and 5. This is equal to 9. Okay, so the number of ones in alpha catenation gamma is the sum of number of ones in alpha and that of in gamma. Okay, so from above it is clear that alpha and beta have the same number of 1. So the number of ones in alpha catenation gamma is same as the number of ones in beta catenation delta, because alpha and beta have the same number of ones and gamma and delta have the same number of ones. So alpha, the number of ones in alpha catenation gamma is same as number of ones in beta catenation delta. So alpha catenation gamma is related with beta catenation delta. Okay, hence R is a congruence relation on A star. Okay, from this we can say that R is congruence relation. Okay, there are some more example of this congruence relation in exercise. Okay, so we'll discuss in our assignment problems. So we'll discuss new topic in the next lecture. This is enough for this lecture. Thank you.